All right, one last type of variable to think about, and that is characters or string variables. These are just literally collections of letters or numbers or whatever, characters. You can make characters with either single quotes or double quotes. So you just write it out very simply, right? My string is a character variable. You can make a vector of character variables. And then you can, of course, have character variables in your data like we do here. When you're making strings and you're putting them together, the paste function, which we already used a little bit, is used to stick things together. So if you put in multiple strings and you use paste to sort of just pop them in, make them one string, to sort of separate, put them right next to each other in a single string. So for example, the paste 0 function with H and LO with a underscore separator will take these different strings and pop them all together, and with a little underscore separating them. So if I do something like this, paste O, or paste of A, B, and C, and let's say D. If I do all of them together, it will do A space, B space, D, C space, D space. I can do a separator, underscore. I can make that the separator instead of a space. I can even do stuff like and. Right? Very easy. I wasn't using paste before. I was using paste 0. The only difference between paste and paste 0 is that the default separator is nothing instead of a space. So I tend to use paste 0 myself because I often don't want a separator. If I want to put a space in, I'll put it in myself. But paste also has its applications. Even if you're not working with string data, you will often run into it. Messy data will often default to character variables. For example, if you have a 1, 000, 000 in your Excel sheet and you read it in, you might end up with a string of 1, 000, 000 instead of an actual number. So you might want to clean that up. And by the way, you really don't want your numbers to be strings. Don't put quotes around the numbers. So that's how we can create our strings. So you will have to often work with text data for doing analysis. Then this is both in your data itself. Also, once we get to data visualization and making graphs, you might want to manipulate a string to create like an annotation on your graph. So the process of working with string data, sometimes it's straightforward. Like you can use mutate in case when to fix a typo. Let's say I thought that January was spelled wrong in my data here. Let's say construction. Right, I got, let's say I want January to instead be Jan, or I want to spell it wrong. I can do construction, mutate, case when, if month is January, give me back January, I don't know, and then everything else just give me back the month that you started with. Now I got, ooh, what did I do wrong? Oh, I forgot to actually name it. Month equals, there we go. Now I got January. So I don't know why you'd want to do that, but if there was something wrong, you could fix it that way. Other common tasks in data cleaning, though, include things like getting substrings from your data, splitting strings, cleaning strings, detecting patterns in strings, lots of different stuff. Now, thankfully, just like with dates, there is a package called StringR, which makes a lot of string-based functions much easier to use. So anytime you're working with a string function, a string variable, and you're trying to do something with it, again, I'd strongly recommend thinking, I wonder if there's a StringR function that makes this easy. Hopefully there is. There's also a cheat sheet for using StringR you can find. So, as I mentioned, making strings, you can use paste and paste 0 to stick strings together, a common task in visualization and data cleaning generally. This is one place where R is a bit annoying relative to Python. In Python, you can just literally add strings together with plus. So you can do something like this, A plus B, and it would give you AB in Python and in a lot of languages. Not so in R, you got to use this paste function, but it's not that hard to use. So paste things together with a separator, and it will pop them all together with whatever separator you had separating them. You can also include, by the way, special characters in here, but the most important of which is \n. That gives you a line break. So I do something like this, my string, right, prints out as my string. I can also do my \n string, which will put a line break in there, which if I use the cat function, which prints some things out directly, it will print it out on 2 different lines. And this is very handy. Again, when we get to data visualization, I might want to create an annotation on my graph with a line break on it, like, hey, look at the result in my graph. And now that will print on 2 different lines. So pasting together annotations and table titles is a great idea. You might also paste together things like multiple columns of data to turn it into a single string like we did with the years. That can be handy. Now, we have the StringR package for doing a lot of different kinds of string editing tasks. And there are a lot of string editing tasks that we might want to do. It makes working with strings as easy as possible. Just like with dates, you always want to ask yourself, hey, I wonder if there's a StringR function that will make this easier to use. Also, conveniently with StringR, a lot of the functions are named very similarly. So if you do StringR and then : : it will pop up all the functions that are in that package, just with other packages. And if I type str, that will give me a bunch of different string functions, which will do all sorts of different tasks for me. And I can sort of look through and see if any of these look like they are the kind of thing that I want. So first thing we might have to do is get substrings. So if you're working with things like nested IDs, for example, let's say you have an NAICS code, which is a 6-digit string, but the first 2 digits of that string, the first 2 letters of that string are a broad industry category. So maybe I just want that broad industry category. I only want the first 2 characters of this string. I'm going to be getting a substring. The string sub function in StringR makes an easy way to do that. Give it the string that I want, tell it what character position to start at and what character position to end at. So for example, string sub of hello from 2 to 4 gives me the 2nd through 4th character, which is ELL. If I can run that, you can see just ELL, right? I can also start from the end. If I do string sub of -1, that will start from the -1th character position, which is the last position, and then go towards the end. So I can go from the -1th position, which is O, all the way to the end by not specifying an end. Give me back just O. Another way to get substrings out is to use word. Word will give you just a certain number of words of the string. So for example, I give it sales space department. There are 2 words in this string, sales space and then department. If I ask for the first word, it will give me back the first word, which is sales, and it will drop the 2nd word. So this is another way to, so lots of data, by the way, will try to stick multiple pieces of information into a single cell that you might need to split out. String split is one way of doing this. So let's say we have A, comma, B. I can use string split to split it at a comma. Anytime it sees a comma, it will split it into 2 separate strings. And then as for, this inconveniently gives you a list of results. I only usually want the first one. So if I do string split of A, B with a comma, and then just after the first option, it will give me those 2 things split into separate parts, right? Instead of A, comma, B, I get A, B as separate elements. If you're talking about already tidy data and you have a column of data that has something that you want to split across, then you can use separate from Tidyr, which will also do this. And so here's an example. So let's say I start with this data set right here, where I have a column that is called category. It's got sales, comma, marketing, and H&R, comma, marketing. I want to split that into 2 columns, department 1 and department 2. I can do that with separate, which takes that category variable and splits it into 2 different variables, category 1, category 2, and it's splitting on the basis of the comma. So anytime it sees a comma, that's how it knows where to space. So it will give me 2 variables here, one for sales, comma, marketing, and H&R, comma, marketing. So that's how we can split strings and make strings and subset strings. How can we clean strings into making them the version that we want? Often strings come with unwelcome extras you might want to get rid of. For example, you might get garbage or white space at the beginning or end, or badly used characters. String trim is a way of removing white space. So for example, let's say I got a string that looks like this, space, 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 hello, space, space. That would be a bunch of extra white space, which can be bad for a couple reasons. One, it looks bad. And for another reason, let's say I have a variable where it's, let's say, sales over here and then sales space over here. And I try to do some sort of group by, but these are 2 separate things, right? They're not the same thing. But if I do string trim, it will get rid of any trailing or leading white space, making these 2 things the same. String squish is the same, but it also removes spaces, extra spaces from in the middle. So if I had, let's say, sales department and sales space space department, string trim won't do anything about that. I still get 2 spaces over here, 1 over here, but string squish will also get rid of those internal extra spaces. One that I use quite a bit is string replace or string replace all. This can take a set of characters that you observe and replace them with something else. So, for example, if I want to fix a typo, I used case 1 to do that before, but I can also use that with string replace. So I did that thing where I made it January, right? I could also do it this way. I could say construction mutate month equals string replace. Start with the month. Anytime you see January, give me back January. And that will give me January. I don't have to give it the entire string. I can just look for a part of a string. Let's say I want to, if anytime I see Janu, give me Janube. And that has the same effect. Now, if Janu also appeared in any of the other months, then that would also pop up there. For example, I can change both June and July. I can say change Ju to Jube. And now I get Juben and Jubilee. So that's one way in which I can, replace one part of a string with a different element, which can be good for fixing typos. Of course, it can also be good for getting rid of things like commas in numeric strings. So I got 1, 000, 2, 003, 004, 124. I can use string replace all, which replaces all the instances of a string and then convert to numeric. So I take the number that I have, I replace all the commas with nothing, and then I convert the result into a number. Notice, by the way, I'm using a pipe inside of a mutate. You can totally do that. And that will give me back 1,000 and 2,003,124. There are also ways of making your strings look a bit prettier by changing the case. I can use string to upper to make everything uppercase, string to lower to make it all lowercase. These are both useful for like matching on strings if I want to make sure that something is the exact same set of characters over here. Like let's say I have, in one data set, I have July for the month name, and the other one I have July. Those are very different strings. If I want them to be the same so that I can compare them, I can do string to upper. Now they are both all caps. For making things look nice, I can use string to title to make things title case, where everything is where the first letter of each word is capitalized, like this. I can use string to sentence to make things sentence case, where the first letter is capitalized and the others are not. Nice for titles and things like that. Lastly, something you might want to do in strings, and this gets a bit more complex, is detecting patterns in strings. This gets, like I said, this is more difficult. I'm only going to sort of brush over the surface here, but this is what are called regular expressions. They look for patterns in strings. So they're basically ways of describing those patterns such that a computer can describe them. Now, the easiest form of this is just looking for the existence of a certain character. So that's technically what we did here. We said, hey, look for a pattern where the pattern is you see a comma. That's the pattern. Simple, right? If you see a comma, get rid of it. But I can look for more complex things than just is there a comma. So, for example, I can look for 0 to 9 for any digit, and then I can do that. So, for example, let's start with the string, my number is 130. Right, that's a string. I can do string replace. Let's look for a digit. 0 to 9. If you see as in any digit, replace it with a 7. Now my number is 730. Now you might notice it only did the first one because regular expressions are difficult. If I want to look for all of them, I got to do that. Where it's going to look for all the numbers, and it's going to replace all those numbers, the 1, the 3, and the 0, with a single 7, right? So like I said, it can get pretty complex. But you can do some common stuff like look for a digit, look for a letter, right? Star to repeat until you see the next thing. It's hard to condense. There's a guide that you can link to right here if you really do want to get into this thing, although you can skip this and still be okay. Here's an example. Let's say that I want to do something like this. I want to use this regular expression. I'll explain what it means in a second. But what this is saying is look for, first of all, a parentheses. The double backslash escapes the special character. Then look for as many letters in capital letters as you like. Look for a capital letter, and then look for as many capital letters as you like. The dot star says keep looking for this thing as many times as you find it. And then another parentheses. So if it sees a parentheses, a bunch of capital letters, and then an end parentheses, that's the pattern that it's looking for. I can replace it with whatever I want. Why might I want to do that? Well, maybe I want to get rid of a stock ticker in my name here. So I've got Amazon, AMZN Holdings, and Cargill Corporation, which also has parentheses in it, but not a place that I want. I don't want to get rid of those parentheses. So I can use string detect to see whether the pattern exists, and I can use string replace to get rid of that pattern. So here I'm finding the stock ticker and getting rid of it, replacing it with nothing. And you can see that it gets rid of the ticker in Amazon Holdings, but does not get rid of the parenthetical in Cargill. So why might I want to do this? Let's do an example of working with a string. So let's say I have a list of county names here, but they've all got the word county in them. Let's get rid of that. So if I look at this data set here, FIPS to names. It's got a bunch of county names in it, but it's got like Artuega County, Baldwin County, Barber County. Maybe I just want the name there. I want to get rid of that part. So let's do FIPS to names. Let's mutate the county name, or just the name, is word of county name, and just the first one. Right now I just get that part. Now that doesn't always seem to work. What I really want to do is I want to get rid of the word county, right? And if I do that, I can do fips to names, mutate, just name is string replace, county name. And if I see the word county, get rid of it. Names. And that has much the same effect, except it does not get rid of this. So when I did it before, I got region instead of region 5. This doesn't affect the region 5 thing. It just gets rid of the word county. Here, by the way, I'm taking that data set and pulling out that single variable name. I'm getting rid of the first word and taking a table of it to see what words appear as not the first word. And you can see that sometimes there's other stuff that I don't want to get rid of, so I don't want to just get rid of that first word, but county is often the thing I do want to get rid of. And maybe parish also shows up a lot. So I can get rid of both of those with a very simple regular expression. I want to get rid of county or parish, well, I'll just do county or parish. And now both of those things will be gotten rid of. Oop, did it freeze? What's happening? Oh, there we go. All right, so that was a little bit of a long video, but there's a lot of things you can do with strings. You can put them together to create new strings. You can use quotes to create strings in the first place. You can try to get words out of strings. You can try to capitalize them or uncapitalize them. You can replace different parts of them. You can get substrings. There's lots of different stuff that you can do. The StringR package is very helpful at letting you do that.